All right, this is section 5.1c, representations of a function. We're going to talk a little bit more about functions. Number 1 has the input of circumference of a finger and the output of a ring size. So you can tell that every one of these inputs has only one arrow going out of it and matches with only one output. So this is a function. Every input has exactly one output. Number 2, the input is the state a person lives in. The output is the team they root for in college football. So Utah cheers for both the Cougars and the Utes, and Nevada cheers for the Utes, and Arizona cheers for the Sun Devils. So Utah has 2 arrows or points to 2 outputs, so this is not a function. Utah cheers for 2 teams. So number 3 wants us to take the information from number 1 and put it into a set of ordered pairs. So we're going to use brackets because this is a set. We're going to pair 14 1/10 with a ring size of 3, 14 9/10 with a ring size of 4, 15 7/10 with a ring size of 5, and 16 1/2 with a ring size of 6, and close up the bracket. It feels weird, but you can have words as ordered pairs too, like number 2. So we're going to pair Utah with the Cougars. We're going to pair Utah again with the Utes. Then we're going to pair Nevada with the Utes. And Arizona with the Sun Devils. Then we're going to close up those brackets. All right, that's how you make ordered pairs out of mapping diagrams. Number 5 has the input of the city a student lives in and the output the high school they go to. As you can see, if you live in Salt Lake City, you could go to East High School, Skyline High School, West High School. If you live in Provo, you could go to Timpview High School, Provo High School, and if you live in Camas, you could go to South Summit High School. So this is not a function. Two inputs have multiple outputs. Number 6, the input is the age and the output is the level of the baseball team. So at age 5, you play t-ball. 6, you also play t-ball. 7, you're in minor league, and 8, you're in minor league, and ages 9 and 10, you're in junior league. So each one of these inputs only has one arrow coming out of it, so this is a function. Each input has exactly one output. All right, moving on. So this is just a picture of all the different ways that functions can be represented. Mappings, tables, graphs, equations, set of ordered pairs, or a story. Those all are the same things, but different ways to represent them. So let's look at number 7. In this story, a candle is 27 centimeters high and burns 3 centimeters per hour. An equation that models this relation is C equals 27 minus 3h, where C is the height of the candle in centimeters and h is the number of hours the candle is burning. So at 0 hours, that candle is still 27 centimeters high. After 1, it's only 24 because it's melted 3 centimeters. At 2, after 2 hours, this is a 2. We're at 21, 3, 18, 4, 15. To make a mapping from this, we're just going to pair the inputs and outputs up together. Here we go. Now that my graph is teeny tiny, but I'm going to put the input on the X, which is hours, and then I'm going to put height on the Y. Here I'm going to go up by 2s, or up by 1s, but skip every other. Here I'm going to go up by 2s. So 0 is paired with 27. You're going to have to kind of plot in between. Wait, 4, 8, 12, 16, 20, 24, 28. 1 is at 24. 2, 21. Got to kind of go in between there. 3, 18. Right here. 4, 15 is right there. So the ordered pairs, you just pair them up like that. 0 pairs with 27, 1 with 24, 2 with 21, 3 with 18, and 4 with 15. B asks if this is a function. Is the height of a candle a function of the amount of time it has been burning? Well, yes, it sure is. Every input has one output, or you can say it passes the vertical line test. No repeating x's. This is 1 here. All right, so let's move on. This one's interesting. We don't really know what the input and output is, but we just get x and y. So let's create our table from the mapping. We have -1 paired up with 0. 0 is paired up with both 1 and -1, so we have to make sure we put that on there twice. 1 is paired with 2, and it's also paired with -2. 2 is paired with 3 and with -3. If we plot this, it looks like that. Oop. This goes down here. Okay, so let's write this as a set of ordered pairs. The best place to get this from is the table, because then you won't miss any. There you go. Is this function a relation, or is this relation a function? Nope. Look at it. Fails the vertical line test right here. All right, moving on. Let's look at 9. Discovery Place Preschool gathered data on the age of each student in years and the child's height in inches. The graph shows the data. Is this a function? Well, no. Look, if I drew a vertical line there, it goes through all of those points. So no, it fails the vertical line test. If you look at the set of ordered pairs in 10, you can see that you have a couple f values that are the same, couple inputs, so this is not a function. duplicate x values. Number 11, we're going to use the vertical line test for this. So if I draw a vertical line right here, it goes through 2 points. So not a function. Fails the vertical line test. So 2, if I were to graph 2, it's an x with no y, it would be a vertical line like that. So you can't pass the vertical line test because if you drew a vertical line on that, it would intersect at infinitely many points. So no, fails the vertical line test. So 13 is something new to us. If you can put an equation into that format, into slope-intercept form, or this is called standard form, with the exception of x by itself, the one that we just did in 12, which is a vertical line, these are always functions. It's a linear equation. Number 14, if you look at the letter grade and percentage, the percentage is not a function of the letter grade because look, you can have a B and you can have 2 separate percentages. You can have an 88 and an 87. So no, B has 2 outputs. But let's look at 15. These ones with just the words can be difficult. I try to make a mapping diagram out of these. It says, is the letter grade a function of the percentage scored on the test? So the percentage is an input. So I'm going to make some up. I'm making this up just so I can visually see this. So I have a 90, a 70, a 60%. And here's the letter grades. A, B, C, D. So if you have a 90, you can only match with an A. You can't get a 90 and get both an A and a B. So this is a function. Each input has one output. So if I go down here to the time of day and the temperature, at 8 o'clock, right on the dot, you can only have one temperature. So this also is a function because every input has exactly one output. Okay. Now if we switch this around, is the time of day a function of the temperature? We're going to put the temperature first. So let's say 90 degrees, 80, 70, 60. And the time of day over here, 2, 3, 4, 5 o'clock in the afternoon, it can be 90 at 2 o'clock and still be 90 at 3 o'clock. So you can have multiple a temperature, you can have one temperature at multiple times a day. So this is not a function. So it can be a certain temperature multiple times a day. Let me write this so you can read it.